All right, good morning. So welcome to Elements of Calculus 2. This doesn't tell me if I am recording, it does like that. So we're going to go through each of the problems on the pretest to make sure that you can do this. Now, I wrote the pretest and just kind of threw up the problems as I was thinking of them. They aren't in any particular order. Don't expect your test to be in exactly the same order. It won't be exactly the same problems. They'll be close. Each type will be on here, but it won't be the same problems. Okay, so I'm looking at this. I'm thinking, okay, we've got a polynomial times an exponential. That screams to you. Please do integration by parts. Okay, anytime you have polynomial times a logarithm, polynomial times an exponent, you should be doing integration by parts. Okay? There's other cases. You may have seen an interview, a YouTube with this LAITE, which stands for log. This is the ones you want to differentiate: logarithm, uh, inverse trig function, algebraic function, trig function, or exponential. Those are the ones you want to differentiate. You don't know and you will never see trig functions or inverse trig functions. So this is a little bit too much for what we need to do. It's kind of like, you don't need a baseball bat to kill a fly. It's not going to work that way. So polynomial times exponent, polynomial times logarithm, those are the two you really have to worry about. That's integration by parts. So let's go ahead and set up our integration by parts. We have let u equal, okay, and please, when you have you're going to make a substitution, please declare your substitution so that I know what the heck you're doing. Whoever's following your work will know what you're doing. Okay, 3x2 du is equal to 6x dv is equal to what's left over, to e to the 2x. And then we'll go ahead and integrate this. We get 1/2 e to the 2x, all right? And if you have to make a little mini u substitution in here to do that, that's fine. Okay. So what we're going to do is we're going to get our u substitution. We're going to say this is 3x squared minus 2 times 1/2 e to the 2x minus the integral of this piece. Okay, this is 1/2 e to the 2x, right, times 6x, and there's a x here. Okay, this. And then we're going to have to say, okay, well, let's clean this up a little bit. So I'm going to say this is 1/2 3x squared minus 2 e to the 2x minus, can I say that 6 over 2 is 3 integral of x e to the 2x? Okay. And then you say to yourself, oh, shoot, we have a polynomial x times an exponential. We have to do integration by parts again. So we're going to have 1/2 3x squared minus 2 e to the 2x minus 3, and then we're going to do integration parts. So we're going to say let u equals x, du equals dx, dv equals e to the 2x, v equals 1/2 e to the 2x. Okay, so we'll go ahead and say, okay, we need this again. This is going to be 1/2 x e to the 2x minus the integral of 1/2 e to the 2x dx. That's this piece right here. Okay, and now we don't have a polynomial anymore in our integration. We can, it's over here, but it's not inside the integral. We can just integrate this. So we're going to have 1/2 3x squared minus 2 e to the 2x minus, I'm going to say 3/2 x e to the 2x. Be careful to distribute both the sign and the value out here. So we have plus 3, and then I'm going to go say over 2 e to the 2x, but we haven't integrated yet. So let's go ahead and do that. So we're going to say this is 1/2 3x squared minus 2 e to the 2x minus 3/2 x e to the 2x plus 3, and there's going to be another factor of a half here, 3 over 4 e to the 2x, and then the last thing to remember, plus c. And that's going to be our answer for this. Now, let me show you a different way to do this. Okay, so that's one way to go. If you watch these things on YouTube at all, you're probably going to come across something called tablature integration. Okay, and I'm going to say, be careful doing this. Please practice this technique before you go off on the test to try it for the first time. So given our integral of 3x squared minus 2 e to the 2x. We decide what we're going to take derivatives of, what we're going to take integrals of. Since polynomials are eventually going to go to 0 under differentiation, we're going to pick the polynomial to be the derivative. If we had a logarithm, we would take the logarithm to be the derivative because we can't integrate the logarithm. So we're just going to write a d and an I here. So we're going to say this is 3x squared minus 2 e to the 2x. And then each row after this, we're just going to take the derivative. Derivative of 3x squared is going to be 6x. The integral of e to the 2x is 1/2 e to the 2x. Take the derivative again, we get 6. Take the integral again, we get 1/4 e to the 2x. Take the derivative again, we get 0. Take the integral again, we get 1/8 e to the 2x. You do this until you get a 0. That's when you know how to stop. And then we're going to fill in our signs. Plus, minus, plus, minus. Okay, they always follow the same rule. You start with plus, change to a negative, go back to a plus, minus, and so forth. And then what we're going to do is we just multiply the diagonals together. Okay. And obviously this is going to be 0 for anything after that, so we don't have to worry. That's why you stop at 0. And we're just going to write these guys down. So I'm going to say that my answer here is going to be 1/2 3x squared minus 2 e to the 2x. I just multiplied this first row and the second row together. Minus 6/4 x e to the 2x. Right, that's this piece here. Plus 6/8 e to the 2x plus c. Now let's clean this up a little bit because you don't want to let the answer go like this. 1/2 3x squared minus 2 e to the 2x minus 3/2 x e to the 2x plus, we're going to get a cancel a 2 here. So we have 3/4 e to the 2x plus c. And this is exactly, let's double check, what we had up here. That looks pretty good for what we have both of them. Now, the reason I stopped teaching this in this class is because I've had students mess this up and misuse it. So I would prefer that you did the regular integration, but I also know that the internet exists, YouTube exists. So you usually come across this this technique, so you're allowed to use this. I'm going to beg you, please practice it before you walk into the test. If you want to use this technique, you don't have to, but it does make things a little bit easier to deal with. So I say thank you very much for watching the video. Good luck with watching the rest of them. Good luck on your exams. And I will see you in the next video. Thank you very much. Pause.